I wanted to work through an example in which we draw the electrical field of an arrangement of charges. In this particular example, it's a fairly simple arrangement of charges. I've got a positive charge plus Q, a negative charge minus Q. They're equal size charges, opposite sign charges, and I place them on the horizontal axis, either side of the origin. And we're going to draw the electrical field. We're actually going to do it two ways. Firstly, I'm going to draw the electrical field using electrical field vectors, which describe the electrical field at individual points in space. And then I'm going to sketch the electrical field using electrical field lines, which sort of more generally describe the size and the direction of the electrical field in the space surrounding the charges. So we're going to do these two ways. I'm going to do the field vectors on the left-hand side. I'll start with that. Then I'll do the field lines on the right-hand side. I'll end with that. I'm doing it that way around because if you meet a new charge distribution, an unfamiliar charge distribution, it's much easier to start with the field vectors to get an idea, a concept of what the field looks like, and then work your way to the field lines, where you sketch the field everywhere in the space surrounding the charges. So in drawing the field vectors, I'm going to pick a number of points in space around the charges, and I'm going to draw the field vectors at those points. I'm actually going to draw the field due to the individual positive charge, the field due to the individual negative charge, and then I'll sketch the field vector for the superposition, the sum of those two fields. And firstly, I'm just going to mark the points that I'm going to draw the field vectors at. Just some important, interesting points in this arrangement that guide us to constructing the field lines. So here's one point right at the center of the distribution. That obviously seems interesting. I'll make another point over here on the far left and over here on the far right. Those sound like those would be interesting. Let's make a point upstairs here and downstairs here on this line that bisects the charge distribution. And maybe also we'll have a point to get a better idea of the pattern of field lines. Over here, upstairs on the left, and over here, upstairs on the right. So I've marked those points. Now I'm going to add to those points the electrical fields from the positive charge, the negative charge, and then the total electrical field. I'm going to do these in different colors. And so the way I'm going to do it is I'm going to change the color of the pen, and I'm going to do the fields due to the positive charge at all of the points. And then I'll do the field due to the negative charge at all of the points with a new color. And then finally, with another new color, I'll draw the total field at all of those points. So positive charge. The field lines of a positive charge point away from the positive charge. The field of a positive charge points away from the positive charge, and it falls off with distance from the positive charge. So let's draw the field of the positive charge here in red, this little vector, this little arrow. And so the length of that, the direction of that, indicates the strength of the field at this point here, the origin. If I want to draw the field over here on the far left, it's going to point away from the positive charge. If I want to draw it over on the far right, it's also going to point away from the positive charge. Now on the left, I'm closer to the positive charge, so the field is bigger. On the right, and further, so the field is smaller. What about upstairs and downstairs here? Well, again, the field is pointing away from the positive charge. And so the fields here will point away from the positive charge. And they're going to be smaller than the field here, for example, because these points are further away. And then finally, I've got these two other points, upstairs on the left and upstairs on the right. Again, the field's got to point away from the positive charge. And the field will be weaker over here on the left, on the right, and stronger over here on the right, because this point is further away from the positive charge. This point is closer to the positive charge. Okay, now let's do the negative charge. So the negative charge is surrounded also by electrical field. The field points towards the negative charge and is stronger if you're close to the negative charge, weaker if you're further from the negative charge. So let's just start drawing those field lines. Start at the center. Field's going to look like this. It's pointing towards the negative charge, and because we're pretty close, it's pretty strong. Over here on the left, field will look like this. Over here on the right, the field will look like this. Again, both these field lines are pointing, both these vectors are pointing towards the negative charge. And since this point is closer, that field is stronger. This point is further away, that field is weaker. Upstairs and downstairs. Again, field lines have to point towards that negative charge. And so that's what I'm sketching here. Both the field vectors are pointing towards that negative charge. And then finally, the 2 points that are above the horizontal axis on the left and right here, the field lines, the field vector for the negative charge at this right-hand point will point towards that negative charge, so straight downwards. Over here on the left-hand side, the field vector, again, will point towards the negative charge. It's smaller here on the left, it's bigger here on the right, because we're closer on the right, we're further away on the left. So that's the fields now, all the individual fields at those points of both the positive and negative charges. And so finally, I'm going to add the resulting field, the net field at each of these points. So it's the sum of the two vectors. It's the sum in my color coding, right, at the red vector and the green vector from the positive charge and the negative charge. Start at the center, we'll add these two vectors together. They're in the same direction. And so the resulting vectors going to look something like this. Both of them point from the left to the right. The resulting vector will point from the left to the right. Let's go over here on the left-hand side. We've got a field vector towards the left and another one towards the right. So they're partially canceling out, but one's bigger, the other one's smaller. So the bigger one wins. There's a small field towards the left-hand side. Similar things happening over here on the far right. We've got a one vector pointing towards the right, one vector pointing towards the left, but one vector's bigger, one vector's smaller. And so what results is a small field towards, in the direction of the bigger vector, towards the left-hand side. So you notice here that both these fields are pointing towards the left-hand side. The field in between the charges, on the other hand, is pointing towards the right-hand side. So that's kind of interesting. What about upstairs and downstairs? So upstairs, we've got these two vectors. They'll be equal strengths or magnitudes. Both of them point towards the right-hand side, but one has a component that's up, one has a component that's down. The up and down components will cancel each other out. The to the right components will add together, and we'll get a field that looks something like that. And the same thing down here. We've got two vectors, they're the same length, because they're the same distance from equal side charges. Their vertical components will cancel each other out, but their horizontal components will add together. We get field vector, something like this blue vector here. And then finally, we got these two remaining points above the axis on the left and on the right. The superposition of the fields here, let me draw them. Are going to look something like this. So on the right-hand side, imagine you drew the red vector first, and then you place the green vector with its tail at the tip of the red vector. You would end up with the tip of the green vector here. And so the resulting vector runs from the tail of the red vector to the tip of the green vector. It's this vector here. And similarly over here on the right-hand side, on the left-hand side. And so this is the pattern of field lines. This is the pattern of the field. This is the pattern of the field vectors around these two charges. And this is very helpful when you want to actually draw field lines rather than field vectors. So now I'm going to draw the field lines on this right-hand plot or graph. And when I draw these, I'm going to use the information that I've collected on the left-hand plot or graph of the field vectors, but I'm also going to use the following things that I understand. If I'm close to the positive charge, much closer than my distance to the negative charge, it's basically, the field's basically going to look like the field of a positive charge because the positive charge overwhelms the field. If I'm close to the negative charge, i.e. much closer than I am to the positive charge, then again, the field will look like the field of a negative charge because the negative charge will overwhelm the field. And then finally, if I were far from the charge distribution, what would I expect? If I went really far from the charge distribution, what I would expect is that, well, I've got a positive charge, I've got a negative charge. Far from the charge distribution, they look like they're pretty close. It looks like almost like a neutral object. I'd expect actually very, very little field far from this charge distribution. Okay, so let me start adding some field lines. Here's one field line I'm going to start with. It's a field line that runs straight from the positive charge to the negative charge. And we know field lines begin on positive charges, end on negative charges. And I'm guided by the fact that, for example, at the origin, the field is from the left-hand side to the right-hand side. What about over here on the far left, on the horizontal axis on the far left? Well, here the field lines will point in the opposite direction, towards the left. The field here we saw at this example point was towards the left. So the field on the axis to the left of both charges is pointing towards the left. And also we saw that the field here to the right of both charges is also pointing towards the left. So that's a good start. I've drawn some field lines along the horizontal axis, but let's expand that into the space above and below the axis. I'm going to draw a couple of lines and then I'll explain them. So this line upstairs here, this line downstairs, these two field lines, I drew them by thinking about this picture of the field vectors over here on the left-hand side. So along this vertical line that dissects the two charges, the field simply pointed from the left to the right. Look at this blue arrow here. Look at this blue arrow down here. And so my field lines here on this vertical line and here on this vertical line are simply pointing from left to right. Now on the left-hand side of the vertical line, we see that the field is not simply pointing from left to right, it's pointing somewhat up. And we see on the right-hand side of the vertical line, the field is also not pointing simply left to right, it's now pointing somewhat down. And that's what I've also sketched here, right? If I'm on the left-hand side of the vertical line, above the axis, the field is going upwards. And if I'm on the right-hand side of the vertical line, then above the axis, the field is coming downwards towards the negative charge. And kind of the mirror is true below the axis. The field lines are coming out of the positive charge, straightening to go left to right, and then returning to the negative charge. So finally, let me add just a few more field lines to kind of fill out the pattern here that's emerging from drawing the field vectors. So this is my final sketch of the field lines of the positive and negative charge. I've added additional field lines that curl out of the positive charge and around to the negative charge. This one upstairs here. And also this one downstairs here curls out of the positive charge towards the negative charge. And I've also added some field lines over here on the far left and on the far right. These are field lines that are escaping off the edge of the sketch. So some field lines from the positive charge escape beyond the region of the sketch. Some field lines that are heading to the negative charge are appearing from the region beyond the sketch. You'll notice that if I'm close in to the positive charge, the field pattern starts to resemble that simply of a positive charge field with the field lines radially emerging outwards. And if you were close in to the negative charge, the field line pattern resembles that just of a negative charge with the field lines approaching radially inwards towards the negative charge. You'll also notice that a number of the field lines don't escape from the sketch, don't escape from the plot. And so that the field beyond the plot, outside the plot, is going to be very weak. And that's because, you know, we've got a positive and a negative charge. Overall, that object's neutral. And so very little field will escape off the plot. Anyway, I wanted to show you that example. It's an example of how we sketch field lines, how we sketch field vectors. I did start with the field vectors because they're a bit more quantitative and they allow you to get a feeling, an understanding of the field. And then you can go on and sketch the field lines, which give you a more kind of visual picture, a more visceral picture of the field. And both methods are good. Both methods are important tools. Both methods we use all the time.